if you know this, but if you've ever looked on YouTube or OpenCourseWare, the greatest lectures in physics are on there. And almost all the great lecturers in physics have used the bicycle as a way of teaching physics. And if you don't believe me, just go on OpenCourseWare and take a look. Richard Feynman, all the great theoretical physicists who, when they teach a class in physics, invariably use the bicycle as a way of demonstrating principles of physics. Well, my version of that is the Coke bottle. And I told you the last time that I think I could teach a whole course in intellectual property just using a Coke bottle. While it may not be the most elegant invention ever created, it really is a wonderful exemplar for different types of intellectual property, all of which we've discussed, from copyrights to trademarks to patents and, of course, trade secrets. So I'm handing out Coke bottles today because, well, I don't have bicycles, first of all, to give to you, but I'm handing out these Coke bottles so that it'll be a reminder to you of some of the things that we've talked about. I'm trying to cover some general principles involving intellectual property before we get into the nitty-gritty next week of the America Invents Act and actually how to draft a patent application. But you need to be familiar with these topics and these concepts generally, I think, in order for it to be meaningful for you when you actually try to understand the America Invents Act or file a patent application. So this is just kind of a little bit of fun, and by means of review and looking forward, here's the actual patent granted in 1915 to the Coca-Cola bottling company for this Coke bottle design. It's a utility patent, so how long does this patent last? We've gone over how long these last. Utility patents, 20 years exactly. Design patents, how long? 14, 15, 16, depending upon when the design patent was issued. And of course, in order to perpetuate these things, as we discussed, one of the things they do is they keep changing the design a little bit. Interesting sort of thing, Coca-Cola has 550 utility patents to its name, the company does, and about 175 trademarks. They get their trademarks granted 100% of the time. Which tells you a little bit about the strength of the Coca-Cola company's reputation in the USPTO. As far as design and utility patents are concerned, only about 58% of the time. So their trademarks get approved in about a year, which is considered fast-tracked. But the utility and design patents take about the same time as the utility and design patents for the rest of us. So just, I don't know, fun fact about Coca-Cola Bottling Company. They just had a new utility patent issued for a Coca-Cola bottle, and I tried to figure out how to download a copy of it from the USPTO website, but I couldn't, which is all, it has bumps all over it. Instead of the iconic sort of linear design, it's covered with bumps. And I didn't have enough time to read up on it, but that's the latest patent. It was granted in 2019, and it took them about 3.5 years to get through, and it was rejected a number of times. But it's a whole new design. Yes?
So why would something like that be a utility patent versus a design patent? Because, like, what is the, do they have to prove there's some benefit to having these bumps on the bottle rather than just aesthetic?
Yes. Yeah, that's right. That's exactly right. And we talked about overlapping protection, you know, so what Coca-Cola wants to do is have as much protection as they can for the intellectual property. And so they look for both design and utility patents on it. But it's, yeah, it's, in order to be, in many times, like with a Coca-Cola bottle, it can be both a design and utility patent. But oftentimes, if it doesn't do anything, it's just a design patent. So if it's a useful device, it qualifies as a utility patent. If it's not a useful device, In other words, if it don't do anything, then it's strictly a design patent. It just looks good. The Mercedes-Benz, you know, the 3, whatever it is, okay? An example of a design patent. It don't do anything. It just looks good and represents the goodwill of the company. If it did anything, it might qualify for utility patent status. Although an awful lot of rappers think it does something because I see them wearing it around their neck attached to a chain. So maybe, you know, maybe that's an example of something that it actually does. Something with your breakfast. Anyhow, some examples of the types of intellectual property that are represented by a Coke bottle. The iconic logo, of course, that we've looked at. The bottle, design and utility patents. The formula, which is literally, you know, written down on a piece of paper and kept in a secure location in Atlanta, Georgia, and only seen by certain executives in the company. Production methods. How do you get the CO2 into the bottle, for instance? Production methods, how do you, you know, how you fill the bottles, how you clean them, how you, if they happen to be polyethylene bottles, how you make them, artificial sweeteners, preservatives, dispensers, vending machines, bottle openers. Anybody ever get one for Christmas or see them at a liquor store handing them out? Again, it's a form of advertising. They own, it is the closest thing to a vertical and horizontal monopoly as I've ever seen. Anything that has to do with a beverage, either its formulation, its dispensing, its bottling, its sale, its distribution, all are subject to either a utility or a design or some other patent or intellectual property protection for the Coca-Cola bottling company. It's quite amazing. But these guys, and by the way, this is the description from the patent, the actual patent issued to the Coca-Cola bottling company for their sweetener, which you'll note contains antioxidants. But if you're writing a claim for a sweetener and you want to distinguish it from prior art, tell the patent office that your invention actually has additional properties like its antioxidant properties. That's an important claim distinguishing Coca-Cola's sweetener from prior art. And what this illustrates is that when you write claims to base and you're advocating with the patent office, make sure that you distinguish yourself from the prior art. And that's one way that this company did it. So anyhow, that's the stuff that was kind of left over for last time. When you look at that Coca-Cola bottle, I hope that in the future you don't look at it the same way as you have before. This is what I wanted to cover today, and this is my favorite subject. I told you I was going to tell you about the story of graphene. I always want to make this class relevant, you know, for material science students. And graphene is my favorite subject, even though I don't know anything really about material science. Because like the Coca-Cola bottle, it really illustrates an awful lot of the concepts that I want to impress upon you as material scientists. We can learn an awful lot from graphene. To begin with, the story of graphene begins with this question, as far as I'm concerned. Does the assertion of formal intellectual property rights in any way inhibit or does it promote the dissemination of scientific information? You know, we've been talking about this. When you assert intellectual property rights, you own them. You and you alone can copy that. You and you alone can commercially exploit that. You and you alone can sell those things. So do you think that assertion of intellectual property rights would in any way inhibit the flow of information or the dissemination of information or scientific knowledge or inventions? That's the question that I have, and hopefully will answer for you today. A lot of people have focused on this because it's an important question. It has an awful lot to do with not only how we share information amongst us, which of course is what Congress wants to promote when it designs intellectual property laws, but also has to do with how valuable your invention is. And I'll explain. So scientific journals are the way we normally exchange information. Who is published in a scientific journal here? Okay. And how do we as scientists and as researchers and as inventors share our information primarily? It's in scientific journals like Nature, and name me some scientific journal. American Medical Association, the New England Journal of Medicine, name me some scientific journals. Which ones were you published in? Journal of Material Science? I mean,
active material. Yeah.
Active material, okay. When you want to learn something about your particular subject in material science, you do a literature search, right? You go to Google Scholar or one of the other search engines, and you pull up scientific papers. That's how we share information. Another way we share information is through the United States Patent Office. When you file a patent, that information becomes public after 1 year. So when you file a provisional patent application, which we'll talk about, you have 12 months to convert it to a non-provisional. Once it's converted to a non-provisional, it gets published. You can literally go to the USPTO website and look it up, okay? And you don't even need the number. All you need to know is the category or the type of invention it is. And when you do searches of prior art in preparation for filing an application for a patent, you yourself need to go to the USPTO website or hire somebody for you to do this and do a search of the prior art. And a search of the prior art involves a review, in part, not only of the information on hand at the Patent Office of similar inventions, but also a search of journals. Because you want to find out what your competitors have done before you. Is your invention, have you created daylight between the prior art and yourself? Because if you haven't, you're not going to be able to convince a patent examiner that your information, your technology is worthy of protection. So one of the ways that we go about doing that is through literature searches and searches in scientific journals. It's how you scientists, you inventors, you researchers share information. They offer an opportunity for scientists to disclose their findings, and it allows them to highlight the importance of their discoveries via the peer review process, and at the same time, it's the principal means by which follow-on research can be done. Now, for scientific discoveries with potential commercial applicability, researchers may seek to establish formal intellectual property right protection. If you have an invention, and especially if you have a bunch of investors who have been funding the research and the development of your invention, they're going to want their inventions protected. And so what everybody does now is they file their provisional patent application before they do any disclosure. Why? Because under the American Invents Act, you only have 12 months. If you do any disclosure and you don't file a provisional within that 12-month period of time, it goes into the, what did the Frenchman call it? Goes into the public domain. You don't own it anymore. So financial investors don't just hand you money, they want their investment protected. And so what they will do with you as the inventor is they'll urge you, before you do any publishing, to protect your commercially exploitable invention by filing a provisional patent application. And so then the question becomes, does filing a provisional patent application, which restricts the ability of other people to practice your technology without a license, does this inhibit the dissemination of information or scientific knowledge? Or is it possible that formal intellectual property rights protection facilitate technological exchange? What do you think? I mean, hopefully I'm going to give you the answer, but I'd really love to hear what you think about this. Do you think erecting a barrier around a particular type of technology and making it impossible for others to practice that technology without paying you a licensing fee, do you think that inhibits the spread of intellectual scientific knowledge, or do you think it promotes it? What would you say?
Well, I think the way I've learned the purpose of a patent for its origins, right, is to protect that person so they continue to make money for a reasonable amount of time.
Right.
But allowing also competition to exist. And so the point isn't to protect you for your life and forever and ever. That's not the Walt Disney, right? That they've somehow gotten. But the point being to actually inspire competition. So this is a way of informing your competitors that this product exists and that they need to do something different.
That is exactly what Congress intends. Sometimes it works out, sometimes it doesn't. Do you know why Ford Motor Company isn't producing all electric cars today? Who owns the patent on the technology for the electric vehicle? Or who did until they released it into the public domain in 2012? Tesla. Ford wouldn't produce electric vehicles because they're afraid of stepping on Tesla's patent. Until Tesla finally decided, gee, if I release this, now this is not altruism, but if I release this technology, I raise the level of all boats. So it works sometimes, but sometimes it doesn't. And sometimes people, inventors like Tesla, have to respond to the market in a way that the market is not capable of responding. There's lots of examples of that that we'll go over, but that's exactly the way it's supposed to. Do you think that's what it does? Not necessarily. You make a great lawyer. It depends and not necessarily are the two best answers you can give. Let me tell you, you know what? I really feel as though I've made some progress with this class. You know, if you walk out of here knowing those two phrases, you know what? That's fine with me. Yes.
I also think sometimes what a patent will end up doing, maybe not facilitating technology transfer of that specific technology, but it could further the industry because people work around it. And so they leapfrog it and create new technology.
All right, I want to know how you're getting into my slide presentations because you always know what the next slide is talking about. The point of this slide is, the intuitive response is if you erect a barrier around a certain technology, you're probably going to inhibit the practice of that technology and the dissemination of information. And in fact, that's what many people concluded based upon empirical studies that were done by none other than the Sloan School, one of my favorite places. But illustrative of this is the story of graphene. This is where I get to tell the story of graphene, because I think it illustrates this concept brilliantly. So everybody's familiar with the graphene matrix. Graphene is a very simple material made out of, graphite, the material found in pencils and in, tennis rackets, handball rackets. It's a single layer of carbon atoms, 0.3 of a nanometer thick, which is 1 million times thinner than a piece of paper arranged on a planar, a flat matrix. Yet it's 150 times stronger than steel and 20% more flexible. It conducts electricity better than copper or gold at a speed of 1 million meters per second. It sheds heat like crazy, and it's transparent as well as totally impermeable. From a material standpoint, it's one of those wonder discoveries. And it was a discovery which was predicted by theoretical physicists for a long time, but no one was able to actually follow up on and actually prove. But like carbon fiber before it, I'm sure that some of the skeptical looks I see on your faces reflect the fact that there is no such thing as a perfect material. But this really, for my money, is perhaps, except for some of the follow-on things that have developed from it, was the latest and greatest, at least back 4 or 5 years ago. So in 2004, researchers from the University of Manchester and the Institute of Microelectronics in Russia developed the first feasible approach for fabricating a 1 atom thick layer. Do you know how they did it? Do you know how they did it? Scotch tape. It was like, I don't know how, of course it was patented and I don't understand it. I've read the patent, but how they created this 0.3 nanometer thick layer of graphene was using Scotch tape. Yes?
Did 3M try to sue them after they used Scotch tape?
I don't think that 3M ever tried to sue them for infringement. If I was 3M, I'd be really proud to be associated with a couple of people that won the Nobel Prize for this, because this invention was at the crossroads of theoretical physics and materials technology for decades, and it took an awful long time for anyone to prove this theory to be correct. But they did. Even though they'd theorized its existence for many years, no one until these fellows were able to isolate it using Scotch tape were able to prove it. But of course it has significant potential for a wide range of uses, including electrode materials, transistors, thermal interfaces, conductive polymer links, corrosion resistance coatings, biocoating sensors, and consumer products from bicycles to aircraft fuselages. Today, who was it that worked on the 777X? Maybe not here today. Part of the my understanding, 777X has the largest wingspan Boeing has ever, longest wings Boeing has ever created, and they're partially made of graphene, as is, I believe, part of the fuselage. Boeing was one of the innovators in creating this in a production quantities and use it as in their 787 aircraft. It was a leap ahead of the competitors at Airbus in terms of materials used, and that's an example of where material science has actually, for a short period of time for Boeing, captured the market. It's flexible, transparent, can conduct electricity, it's lightweight, and it's just wonderful from a material standpoint, and it's the 21st century version of, it's the equivalent to carbon fiber and the development of steel, many would say. And the fundamental scientific discovery was published promptly in Science in 2004. But because of its commercial application, the authors of the study patented their Scotch tape technology. And because of the commercial applications of this, there was, once published in Science magazine, there was a great deal of research that followed it on. Everybody wanted to get in on exploiting this new material. And the fact that the fabrication and characteristics of graphene involves some very basic research questions that were applicable to theoretical physics resulted in these folks getting, as I said, the Nobel Prize. Now, given the dual nature of its research, both physics and material science, many graphene researchers chose not only to disclose their findings through publication in a few selected journal platforms, but they also submitted applications to the USPTO for intellectual property protection because many of them were being funded by investors. So in addition to publishing their work in Nature magazine, the first thing they do is file a provisional patent. Now, the assertion of formal intellectual property rights has become so prevalent a form of disclosure that many commentators, and I think this is the magazine you might have mentioned, Nature Materials, or it's a different journal, but many publishers of journals became concerned about whether or not their journal was going to be reflecting the latest advances. Because if the authors are kind of keeping those things close to their vest so as to be able to commercially exploit it over competitors, these journals began becoming concerned that they weren't getting the latest information. So they were concerned about whether or not assertion of intellectual property rights was inhibiting the free flow of scientific knowledge. And like contributors to any platform designed for knowledge sharing and exchange, scientists and the editorial staffs of these of Nature and some of the others were concerned that their journals, which had previously been the primary platform for sharing scientific knowledge, were being undermined. So in 2012, some famous researchers, Murray and Stern at the Sloan School, conducted a study in order to evaluate the interrelationship between scientific journal publication and patenting, and the incidence and impact of patent paper pairs in two particular journals that they chose, Nature Biotechnology and Nature Materials. We went over what a patent paper pair is, but just for review, it simply describes when someone files a patent application and also publishes a paper at the same time. In other words, instead of just filing a scientific paper, which is the way it's traditionally been done, getting intellectual property protection for your invention or your technology at the same time. That's a patent paper pair. And the question for the Sloan School was, does this inhibit, does getting simultaneously intellectual property protection for your invention inhibit the dissemination of scientific knowledge? And the study showed that it did. And let me tell you how they did it, because it's important for you to understand this, especially if you're going to file a patent application yourself. I want to talk just a moment about the methodology the Sloan School used. What they did is they did a citation analysis. And that's no different than something that every one of you will do when you file a patent application. A citation analysis is simply an analysis of the number of times that a patent has been referenced by either a prior patent or a present patent. Backward citations are patents that are cited by a specific patent. So if you file a patent application, and in your patent application you refer to previous patents as part of the prior art, that's a backward citation. A forward citation are patents that cite a specific patent. So, for instance, the number of times a patent has been mentioned by a particular invention. A useful, efficient, and increasingly utilized indication of the value of a patent is the number of times it has been cited by later patents. Okay? Does anybody know what a patent pool is? All right. Well, in addition to these companies like Microsoft and Apple and Samsung and IBM, who have these enormous patent portfolios, oftentimes inventors form little groups so they can compete with the big companies of what's called patent pools. And basically it's inventors in the same area, let's say material science or graphene, people conducting research in these areas all get together and share their information and their patent technology. You pay a licensing fee to the other people, but there is power in numbers. The reason why IBM was granted 9,100 and something patents last year alone is because they're enormous and they have tremendous resources. How do you compete with IBM? Well, one of the ways you do it is instead of just staying in your garage and working on your invention, you get together with other patent owners, other inventors, and you form a patent pool. Hopefully in a discrete area where you can all contribute to a particular invention goal. And in many ways, those small pools are better than the big companies because you're more nimble and you can react better to the market, and you're just more agile than the big companies are. Big companies have a tremendous advantage in terms of money, and the number of researchers and monkeys that they can put in a room all working on the same thing at the same time. But a patent pool oftentimes proves to be more agile and inventive and creative than some of the big companies. So when you're doing a citation analysis, you can go to the USPTO website and you can punch in Adidas. All right, let's say you're working on a new brand of running shoe. You punch in Adidas, and what you'll find, you'll come up with 1,300 patents or thereabouts. And so there's your pool. There's your citation pool, if you will. And then if you're looking for a particular type of patent, let's say the design of the upper part of the shoe or laces, then you put in that word, okay, and then the citation analysis will restrict the number of Adidas patents down to those that have to do with laces or uppers or soles or inners or generally materials. So in this way, you can determine what the prior art is and whether or not, of course, you've put daylight between yourself and the prior art, all right? But another way of determining whether or not scientific knowledge is being disseminated, the Sloan people knew, was to analyze citations. How many times is a patent mentioned in the literature and in the USPTO's database? That should give you some idea as to whether or not the corresponding literature is being inhibited. Are they filing for intellectual property protection and somehow inhibiting the spread of that information through scientific literature? And the way they did it is citation analysis. So just a couple more words on citation analysis. Is one of my competitors working on a similar product? Which technologies and products are highly valuable and how are they related? Let's go with an example. You do a citation analysis in Graphene and you find out that a particular patent is mentioned 5,000 times, okay? And you then do a search on a particular subcategory, and you find out that that patent is mentioned by other patents in 99% of the cases, okay? You do another search, and you find out that that patent is only mentioned 10% of the time. Which patent is more valuable? It's the patent that's being mentioned very often. Most likely that's the more valuable patent because that's the technology that has a demand out there. Okay, inventions follow demand. Commercial use of patents follow demands. So the more a patent comes up in a search of the database, in a citation analysis, the more valuable it's likely to be. And that's important if you're going to try to attract inventions. If you have a better mousetrap, you've worked really hard on this mousetrap, you think it's really commercially viable, well, how do you put a value on this? Well, you do a market analysis and how many mousetraps are sold in a year and so forth, but also in terms of valuing the technology that goes into your mousetrap, you do a patent citation analysis and you find that your technology is mentioned more than any other technology. That's something that you literally bring to the bank, and when you're asking for a loan, explain, or to venture capitalists, explain that why your invention is more valuable than others that they're considering. I've already covered patent paper pools. I thought I'd give you some examples of patent owners. Coca-Cola, 550 utility patents, 175 design. Adidas, 1,200. I think it's closer to 1,300 now. Look at Nike, 20,000 design or utility patents. IBM, 9,100 in 2019 alone. Samsung, 5,850 in 2019 alone. Apple is owner of 75,000 utility or design patents, and Microsoft, 90,000 utility or design patents. this gives you some idea of what the big companies own just in terms of their own portfolios. And if you add Nike and Adidas and every shoe manufacturer, you're going to get many, many, many more patents concerning that technology. But this gives you an idea of the type of pools that are available, that exist in terms of technology protection. So I sort of already gave this example. Suppose that a company is interested in assessing the value of ABC patent, let's call it a mousetrap, which was issued by the United States Patent Office in April of 2010, and which was placed in a classification category. That's an actual classification category, by the way, G06F. All patents fall under a series of classification categories that are established by international treaty, okay? The IPO establishes all categories, and so the USPTO uses the classification system from the IPO. And so if you file a patent application, you have to come up with a category that your patent belongs in. So I just picked this arbitrarily, but that's the electric digital design data processing. The analyst could identify, say, 5,755 patents. This is an actual example I think my office did, within 3 months of the issue date of April of 2010 in that particular class. And then you count forward, if you count forward all the citations received by each of those patents. If the ABC patent received more forward citations than, say, 99% of all the other technologically similar patents of the same age, that would be an indicator that the ABC mousetrap is more valuable than all the other patents. And that's what a company or investors or somebody like the Bain Group or venture capitalists are going to want to know when you file your patent application. That determines whether or not you're worthy of the investment. So the citation analysis shows the forward citations per patent grouped. Basically, if you do it, it comes up in a pie chart. I invite you all to go to the USPTO website and try to perform a citation analysis. It's really user-friendly. It's like anybody can use it. It's really made so that the public can do studies of prior art. And really what comes up is a pie chart. And of course, your particular patent, the one that you're searching, will be a slice of the pie chart. And you can literally see where most of the patents are being issued and where the technology is. Yes?
When you do a search of prior art, what's like the bar that says you've exhausted your search? You've gone far enough?
Well, there is no bar. You know, it depends on the invention and the prior art. You want to be as thorough as you possibly can be because you don't want to be embarrassed in front of a claim examiner. That's why an awful lot of inventors use services to do citation analysis. You know, I don't think a citation analysis is beyond the ken of anybody in this room. And so it's pretty easy to do and to establish where that bar lies because you can look, all it does is take time, at every single patent that has been issued in that category. So you look at the latest patents that have been issued to Adidas, and you compare what you've done to what Adidas has done, and you say, hey, I think I have something here. Okay, what you're looking for is something that someone has already done to make sure that you're not infringing, and that you have some daylight between you and prior art. But it really is an easy thing to do. You just you have to identify the category. You have to know what your invention is, but of course the inventor knows what it is. You go to the USPTO website, you look it up. It's all right there. Usually you don't have to go through 90,000 patents. You're probably gonna go through 100, okay, or something like that. But that's about the number that you're going to be able to get a sense in what the prior art is. You can do that in a night watching TV, actually, okay? So back to the Sloan study. So they categorized patent paper pairs in two groups. the pre-granted period with no formal intellectual property rights and the post-granted period after IPRs had been issued. In essence, they performed what was a citation analysis. And what they noted is that the models that they used established that patented articles were associated with a statistically significant and strongly negative reductions in annual forward citations. So the conclusion they came up with sort of conformed with what you might consider to be the intuitive answer to whether or not the erection of intellectual property barriers inhibits the spread of scientific knowledge. At least according to Murray and Stern, it did. They found that it resulted in a 5.2% decline in annual forward citations in the initial patent year. There are some other studies that I cite in the materials. You can happily go to the website and look at them all, but what their conclusion was that basically patent paper pairs significantly hindered the dissemination of scientific information. And the question is, was that correct? That's the question, at least when I read the study, I asked myself, was that correct? And when I first started teaching this course 5, 6, 7 years ago, whatever it was, the answer wasn't as clear to me then as it is now. There are some other studies that I cite. This one by a Montreal Polytechnical Institute. They talked about the impact of patent paper pairs on the quality of biotech papers, and they found that it was negative. There's some other studies involving industrial versus academic patents, some other stuff. I talked about Tesla. Yes?
In the Montreal study,
yes.
they quantify
Yes, sure. How do they quantify quality? And that is what they used is they broke it down into university-owned patents and commercially owned patents. University-owned patents are usually considered higher quality patents because they involve basic research. Commercial patents are looked upon with more skepticism and as being lower quality because they tend to focus purely on the commercial aspects of something. I'll give you an example, Coca-Cola bottle. Not a lot of basic scientific knowledge in that, okay? But the basic research that goes into something like gene editing, okay, which many of those patents are owned by universities, reflect fundamental scientific knowledge. And that would be considered a quality patent, okay? So that's how they, in that particular study, qualified or distinguished between quality and non-quality. It's really university versus commercial patents. Yes?
Just the previous study that you mentioned, the Sloan one, kind of raised concerns about the motivation of some academics in their research. A lot of them are driven by the prospects of remuneration for their inventions as opposed to interest in what they're actually researching.
And I can sing that tune in 2 notes. Yeah, that's absolutely true. That's absolutely true. And it's a problem that, you know, the Sloan School study wasn't the first to reveal. It was certainly something that, you know, maybe they should have controlled for. Anyhow, then there's Nantucket Lyme disease. This is information that was funded by the Gates people who, you know, who give all of their technology away. I had a slide up there about Tesla. It was 2014. Toyota did the same thing with respect to fuel cell technology. Zuckerberg, you know, in what I would consider a very cynical, altruistic gesture, donated or created an open software project for AI, but of course, who's going to be the primary beneficiary of that? You know, it's Facebook. So, but it's the same with Tesla, and it's the same with Toyota. Is the same with Facebook. All of them were responding to the fact that intellectual property protection inhibits the development, at least the commercialization of certain technologies. And so certain patent owners have decided that they're better off releasing their technology so as to overcome this inertia. And I mentioned the Nantucket Lyme disease research that the Bill Gates Foundation did. They fund all this research. The only price is that you have to make it publicly available. Everything goes into the public domain. Anyhow, I want to, in the time we have before you go, I want to talk about literally what happened when it came to graphene, because this is where I get to prove the Sloan School wrong. Apart from the mechanical exfoliation of graphene using Scotch tape, what happened when they controlled that technology is just what you said. Other people went out and said, well, there's more than one way to skin a cat, to create a graphene matrix. And what happened is they developed different ways of doing it, including liquid exfoliation, electrochemical exfoliation, and chemical vapor exfoliation. So where the original inventors used Scotch tape and got the Nobel Prize for it, and erected a technological and commercial barrier around that technology, it didn't in any way inhibit the advancement of that technology. I would argue it in fact facilitated it, because what it did is it made people like you think, well, there's got to be another way of doing this. Here are the different methods for exfoliating. This is the electrochemical exfoliation method. For those of you who want to look it up, it's in the slide presentation on the website. But this is an example of where someone just said, look, there's got to be a better or a different way of doing this. Profit is a tremendous motivator. If you're looking to isolate graphene so that, and you're a researcher at Boeing and you want to make billions of dollars in aircraft, you're going to try to think of a different way of doing it. And that's exactly what this research indicates. Erection of intellectual property barriers does not inhibit, in my opinion, the advance of scientific or the dissemination of scientific information. I think it facilitates it. So graphene is supplied as nanoplatelets, which are just 3 to 7 atoms thick. The big challenge is to achieve a near perfect dispersion of graphene in the master batch of epoxy resin for prepaid carbon sheets used to construct, well, this time bicycle frames, but now aircraft parts. These methods that the chemical, the electrochemical, and the different methods for exfoliating graphene have all developed ways of improving the product. So nowadays, despite what the Sloan study said would happen, most of your bicycle helmets contain graphene. Most of your high-end bicycles contain graphene, either in the frames or in the wheels. At the presentation of a new graphene frame, this bicycle manufacturer was able to reduce the weight of the frame by 50%. You can imagine what that does, underneath a Tour de France rider. And I know that Don has been talking to you about lightning materials and bicycles, so you might want to mention graphene to him and see what he knows. In fact, I think I have a graphene bicycle I'm going to bring in. He and I are both has-been bicycle racers, and so I have some very expensive bicycles that I'll bring in that have graphene in them. There's a picture of the graphene bicycle frame. It's really great. It doesn't require any internal wiring because it conducts electricity so well. This bicycle is actually part of the rider. In other words, all your biometrics are actually, it can be powered on a device that runs through the frame of this bicycle. So you get your heart rate and your cadence and the watts that you're producing, all of this information. And it's all run through a bicycle without wires. And that's a good thing because wires create resistance, and resistance creates slow bicycles. So the point of all of these inventions, that all of these advances in graphene, from the aircraft industry to the bicycle industry to basic research that's being done in universities and companies around the world, is that patent paper pairs really, in my opinion, don't inhibit the spread of scientific knowledge. What they do is they spur it. They cause more science to happen. So I disagree with what the Sloan School did. And I think one thing that you pointed out is the authors of the Sloan study, as the authors of any study should be guided by, know your data. Understand your data. Because if you don't understand your data, the conclusions that you're going to reach are probably going to be wrong. It just doesn't do to find something statistically significant, a delta. You need to understand why that delta exists. You have to understand your data. It's just not an empirical driven analysis, especially as you can see here. Understand your data and you're more likely to come up with better conclusions than the Sloan study did. Maybe if you do, one of you in this courtroom will be running around with a Nobel Prize because they were able to isolate something on a strip of Scotch tape. Anyhow, that's all I got for you today. Next week we get into the nitty-gritty. That's the story of graphene. I hope you never look at a Coke bottle the same way again. But we're going to go into the America Invents Act, which is the latest formulation of Congress's act with respect to intellectual property protection. And we're going to learn how to do a patent application, how to write a claims section. I'm even going to bring in some prototypes for you to see from real cases. Hopefully that will inspire you to become the next generation of millionaire inventors. That's what I think I'm looking at. So, any questions, any comments, suggestions? Okay. Have a nice day.